Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas from Maths faculty. Let us go to the today's class. Actually we have completed so many exercises. Synopsis, we are in synopsis 5, right? So this is about the rational numbers. We have discussed what are rational numbers, what are irrational numbers, and their properties also we have discussed in our previous classes. Please visit the previous classes. Now, practice sheet. Already 9 problems we have completed. So let us go through the next problem. So yesterday we have discussed about that pure decimal and mixed decimal. Pure decimal or pure recurring decimal or mixed recurring decimal. So let us revise once again. So pure recurring is nothing but repeating. Recurring is nothing but repeating. So this is mixed recurring. So that means while you are observing a rational numbers are represented with the letter Q. Nothing but rational numbers are in the form of P by Q, and where P comma Q belongs to integers and Q does not equals to 0. We have discussed about the rational numbers like 3 by 4, 5 by 6, minus 1 by 3. They are in the form of P by Q, right? So these are all rational numbers. They are in the form of P by Q. These rational numbers also expressed in the form of decimals. Like the rational numbers having a decimal form, that is nothing but a terminating decimal or non-terminating recurring decimals. Non-terminating recurring decimals. Okay? That means terminating decimal means there is an end for the decimal. That means the decimal value will be end after some decimal digits, like 5.637. That means the value of one of the rational number is considering as 5.637. It is a terminating decimal because the value is stopped here. Let me tell you that, for example, 15 by 25. This is a rational number which are in the form of P by Q. Now let us simplify this. Let us write it in standard form after cancellation both of them, because both are having a common factor 5. Both numerator and denominator will be cancelled in 5 table. Here 5 table 3 times, here 5 times. So nothing but 3 by 5. While you are doing the division like this, the denominator always divisor, numerator will be dividend. Okay. Now 5 table 5. While you are observing 3 here, dividend 3 is smaller than 5. That means 5 zeros are 0. Remainder 3. Now put point, decimal point, take 0. That means 5 table in 36 times. So what is the answer here? 0.6. I don't get any remainder here. So nothing but 3 by 5 can be expressed as 0.6. That means the decimal value is stopped here 0.6 at 0.6. That means it is terminating decimal. Okay, na? That what are called non-terminating repeating decimals? Let us see. For this also I am taking one example here. 1 by 7 I have taken. Now let us write the denominator is always the divisor and the numerator will be dividend. Okay. Now 1 is less than 7. So 7 zeros are 0. So remainder 1. Take point and put 0 here. Now 7 table, 7 ones are 7. Remainder 3. Once you kept the point, for every subtraction we can take 1 0 here. Okay, 7 table 30 won't come. 7 fours are 28. Again remainder 2. So we can take the help of 1 more 0. 7 twos are 14. Again remainder 6. Take 1 more 0. 7 eights are 56. Again remainder 4, I am continuing here. Again remainder 4. So take one more 0. 7 5s 35. Again remainder 5. Take one more 0. 7 7s 49. Again 1. Still, see here we are starting from 1. Again 1 is coming. That means again all this process will be continuous like that. That means 1 4 2 8 5 7. Again 1 4 2 8 5 7. 1 4 2 8 5 7. Like that it is repeating like that. That means here 1 to 7, these all decimal numbers. These all decimal digits are repeating continuously like this. So this is non-terminating. Non-terminating means there is no end for the decimal points. They are coming like that only. Decimal digits, there is no end for the decimal digits. They are continuous like that. So that's why it is non-terminating and repeating. That means some of the digits are repeating continuously like this. Okay now. So nothing but the rational numbers are in the form of terminating decimal or non-terminating repeating decimal. Nothing but recurring decimals. Okay now. Now what are pure recurring and what are mixed recurring? That means in non-terminating repeating decimals, again there are two types of decimals are there, pure recurring and mixed recurring. Pure recurring means, for example, 5.637 or 637, 637. That means if you are observing here, 637 is repeating like this and so on. This symbol indicates and so on. That means it will come like that only. So in the place of 637, continuously there the digits are repeating now. So we can write that 637 bar. That means these three digits are repeating continuously, and that too while you are observing after the decimal point, all the digits are repeating like this. This is called pure recurring. Okay, same question if it is given like this 5.6 37 37 37 like that. Only 37 is not 37 is repeating but not 6. So that means we can express this one as 5.6 37 bar. 37 bar. That means only the digits 3 and 7 are repeating. Here 6 is not repeating. That means after the decimal point while you are observing the digits, here all digits are not repeating, only few of them are repeating. One is left like that. This type of recurring numbers are nothing but mixed recurring numbers or mixed repeating numbers. Okay na? Now did you understand what are pure recurring and what are mixed recurring? Pure recurring means after the decimal point all the digits are repeating continuously like that. Or mixed recurring means after the decimal point it will leave some of the digits and remaining digits only repeating. Okay. Now coming to the question, the number which cannot be, a decimal number in which at least one digit after the decimal point is not repeating. At least one digit is not repeating after the decimal point. After the decimal point at least one is not repeating means mixed recurring. Very good. It is mixed recurring. Clear? Yeah. So for your answer for 9th question is mixed recurring. Mixed recurring decimal. Clear? Yeah. So rational numbers are in the form of P by Q. While you are converting the P by Q form into decimal, there are two types of decimals are there. What are the terminating decimals and non-terminating recurring decimals? In non-terminating recurring decimals, again we have pure recurring and mixed recurring also. So this is the topic about the pure recurring and mixed recurring. Now let us go to the next question. Now while you are observing here, the number which can be expressed in decimal form either in terminating or in repeating decimals. That means while you are expressing any fractional number or any rational number or any number in the form of decimals, it can be terminating decimal it seems or non-terminating recurring decimal or repeating decimal. Such type of decimals are called rational numbers. Am I right? This is the decimal form of a rational number. How the decimal form of a rational number? Terminating decimal or non-terminating repeating decimal. They are called rational numbers. Irrational numbers means they won't terminate. They never terminates. They are non-terminating, non-repeating. They won't be repeat also. All different digits will come. Okay now. So rational number means terminating or non-terminating, repeating. Irrational numbers means non-terminating, non-repeating decimals. So here the question is asking about if you write the any number in the form of decimals, either terminate means they will end, nothing but rational numbers, or repeating, that is also rational numbers. So the question answer is rational numbers or rationals. Okay. Let us see the question number 11. Now the mathematician who was first to discover the rational numbers is nothing but famous mathematician Pythagoras. Okay, the name of the mathematician is who discovered the rational number first is nothing but Pythagoras. Okay, now question number 12. Yeah, let us see this. Yeah, if n is not a perfect square, then root over n is dash. So this is about the irrational numbers. So this problem we will discuss when the irrational number topic comes. Okay, na? So I think 12 and 13 all about the irrational numbers. Let us go to the exercise 1 problems. Exercise 1. Okay? Yeah. The standard form of a number 10 by minus 35. Standard form of a number 10 by minus 35. So while you are observing here, we discussed about the standard form, the rational number. While you are observing numerator and denominator, both of them must be in simplest form. That means there is no common factor between numerator and denominator except 1, because 1 will be the common factor for every number, right? So except 1, there is no common factor between them, and it doesn't have negative sign in the denominator. It does not have any negative sign in the denominator. Okay? Now here denominator having the negative sign and 10, 35 having a common factor 5. Both will come in 5 tables. Now let us simplify this by cancelling the numerator and denominator. Now 5 table, 5 2s are 10, 5 7s are 35. Then what is remaining? 2 by, here minus symbol also there, minus 7. 2 by minus 7 is simplest form. 2 by minus 7 is simplest form, but not standard form. Standard form means the denominator should not contain any negative integer. That means the rational number must be in simplest form, as well as it does not contain any negative symbol in its denominator. So now I am transposing this negative symbol to the numerator. So minus 2 by 7. This is the standard form of a rational number. Okay, na? Nothing but 10 by minus 35. Let us go to the question number 2. Right. So a rational number between 2 and 3. The rational number between 2 and 3. While you are taking that, we have discussed in our earlier classes, that is, if you take any two numbers, whether they are natural, whole numbers, integer, whatever it may be, if you take any two numbers, between them there are infinite number of rational numbers will be there. Here between 2 and 3 also there is a infinite number of rational numbers. There are infinite number of rational numbers. Okay, but here asking that rational number between 2 and 3. So this type of problem, if A and B are any two rational numbers, A and B are any two rational numbers, then what is the rational number between them? That is nothing but A plus B by 2. This is the formula for finding the rational number between any two numbers. So let us consider A value is 2, B value is 3. Substitute here, in the place of A write 2, in the place of B write 3. 2 plus 3 by 2. 2 plus 3 is nothing but 5. 5 by 2. This is the rational number which is lies between 2 and 3. Okay now? Yeah. Let us go to the next problem. Yeah, problem number 3. Name the property of addition is used in the 2 by 3 plus 4 by 9 equals to 4 by 9 plus 2 by 3. So we have discussed about the properties, right? What are the properties? Closure, commutative, associative and distributive property. Now while you are observing here, first number, second number. Let us take this one A and second one is B. That means 2 by 3 value A. Here also have 2 by 3. So A. 4 by 9 value is B. This is also B. So middle what symbol? Plus symbol. A plus B. This is B plus A. Here equals to. A plus B equals to B plus A. If you add any two numbers like any order, 2 by 3 plus 4 by 9 or 4 by 9 plus 2 by 3, the answer will be same. Okay, no? So from this, we can say that this is the property using for addition is commutative property. What property? Commutative property. We already discussed in our earlier classes. Please watch the videos. Okay. Please note it, children. Yeah, let us go to the problem number 4. Okay. Yeah. See here, name the property. This is also a property, that is 2 by 5 plus 4 by 7 plus 5 by 9, that equals to 2 by 5 plus 4 by 7 plus 5 by 9. Same numbers are there, but the position of the bracket only changes. So what property it is? Very good. Associative property. Associative property. Okay? Right. So let us go to the next topic. Problem number 5. Next question. Name the property. This is also property. 5 by 6 plus minus 5 by 6 equals to 0. We discussed that for 5 by 6 minus 5 by 6 both are opposite sign. That means for every positive rational number there exists a rational number whose sum is 0 is nothing but additive inverse. What is that? Additive inverse. That means when you add any two rational numbers, you get the answer 0, means we have to decide that each of the number is called additive inverse of other. So this property is additive inverse. Okay, now? Next, question number 6. While converting the rational numbers into decimal, the process of division terminates the decimal is. Terminates the decimal. When you are doing the division of a rational number, the process is terminating the decimal. It is nothing but terminating decimal. Exactly terminates. I told you already the rational number are in the form of two forms, terminating or non-terminating repeating decimals. But you are asking it is terminates. Terminates means terminating decimals. Terminating decimal. Okay. Let us see next problem. The decimal form of 5 by 210. Decimal form of 5 by 210. So we need to directly do the division. but I am going to do the cancellation first. Before that, both will cancel in 5 table. 5 ones are 5, 5 fours are 20. Here 1 remains 10. 5 2 is 10. So 5 by 210 is nothing but 1 by 42. 1 by 42. They are asking the decimal form. Take it. Denominator always divisor, numerator always be dividend. Okay na? Now 42 table 1 won't come because 1 is smaller than 42. So 42 zeros are 0. Again 1. Again it is not satisfying. Put point. Take 0. Again 10 is smaller than 42. Again 0 you keep. It will be 100 then. 42 table 42 2s are 84. 100 minus 84 is nothing but 16. When you keep the decimal point, we can take 1 0 for after every subtraction. Okay na? Now 42 table 4 times it crosses 160. So I am taking here 3 times. 126 will be the answer. Then 34, right? 34. Again 0. So nearly 6 times, 8 times you try to take. 8 times is 344 I am getting. But here 7 times I am going to take. 7 2s are 14. 1. 7 4s 28 plus 1 29. Now subtraction 0. 13 minus 9 is 4. 46. You are getting right? Sorry. 8 times we will try to take. Yeah, 42 table 8 times. 8 2s are 16. 1. 8 4s 32 plus 1 33. You are getting here 4. But while you are checking that answer is given, answer is not given. Actually 5 by 210 is continuously repeating like this. Let us identify that. Then we need to decide the one of the options. The options are given. It is terminating decimal, non-terminating repeating decimal, non-terminating non-repeating decimal, or none. Let us see this. It is repeating or not. Okay now? Let us take 0 here. It becomes 40. Even though it is not sufficient to this, take 0. Here 400. 42 table here. Let us take for 9 times. Yeah, 9 times here. So 9 2s are 18. 1. 9 4s 36 plus 1 37. Here 2 remains. Here 9 means 2. 22 again 0. 220 nearly 5 times, right? Yeah, 5 times 210. Again 10. Again 0. Means 100. 100 means again here onwards starting again. This is the 100 again. Okay? That means same repeating. That means 0 to 38095. Again 0 to 38905 like that will come. Okay na? Sorry, 23895 like that will come. So from this we can say that some certain period, these digits, some certain period is repeating like this. We can say that it is repeating decimal, nothing but non-terminating repeating decimal. So your answer is non-terminating repeating decimal. Yeah, actually I have done this process, but without the process also we can recognize it easily. How to recognize that? Let us see this. I am explaining that model also. Very easy. Without doing the regular division, we have a condition to identify that. Let us see that condition. Same question, 5 by 210. Now first of all, we should make them into simplest form. To identify that, we should make them into simplest form. That means do cancellation here 1 time, 42 times. Nothing but 1 by 42, still there is no cancellation. Only 1 by 42 remains. Now, observe the denominator. What is the denominator? 42. Now, I am finding the prime factors of 42. The 2 table 21 times, 3 table 7 times, 7 table 1 time. So, 41 I can write as 2 into 3 into 7. So, when you convert the given rational number into the standard form or simplest form, then check the denominators. in the form of prime factors. What are the denominators here? 2 into 3 into 7. We learn the condition, that is, if the denominator having only 2's or only 5 or 2 into 5 combination. Only 2's means 2 can be 2 into 2 into 2, like that. How many times it can be? It can be in the denominator like 2 table, 2 into 2 into 2, like 10 times or 20 times it can be there. The number will be terminating decimal. Entire rational number will be terminating decimal. Okay, same like 5. 5 into 5 into 5, 10 times or 20 times or 35 times, whatever. Only 5 is there in the denominator or only 2 is there in the denominator. We can consider this is a rational number in the form of terminating decimal. Okay, now. But, and one more condition, 2 into 5. Only product of 2 and 5 are their combination. Nothing else. No other number should not come in the denominator. Only the numbers, only 2's or only 5's, and 2 and 5's, both it can be, but except 2 and 5, we should not find any other numbers. See here, I can find 2, but extra numbers 3 and 7. Extra numbers are 3 and 7. So that's why we can say it is non-terminating repeating decimal. Okay, na? Only denominator 2 or only denominator 5 or 2 into 5, we can directly say that it is a terminating decimal. Okay? Yeah. Check. Now let us go to the problem number 8. Now please note this one. Let me finish 8th problem also, then you can write both of them together. Yeah, 8th one, the sum of two irrational numbers. The sum of two irrational numbers, we'll go to discuss this value or this question when we get that irrational numbers concept. Okay, na? So after all the rational number problems are completed, then we'll go to the irrational numbers topic. Okay. Now 9th question. That is, if 3 by 4 into 5 by 3 into 9 by 5 into a by b equals to 9 by 4. We need to find a by b value. Here all 1, 2, 3, 4, 4 rational numbers. If they multiply, their answer is 94, 9 by 4 it seems. So let us check that cancellation is availability or is there or not. Numerator 3, denominator 3 cancel. Numerator 5, denominator 5 is cancelled. What is remaining here? Numerator is 9 is remaining. Denominator is 4 remaining into a by b equals to 9 by 4. But we need to find a by b value, only a by b value. Let us write a by b here. Now here 9 by 4 is multiplied. When you transpose it divides, nothing but it will be reciprocal to other side. So 9 by 4 into 9 by 4. This 9 by 4 when you transpose this it becomes 4 by 9. Again numerator denominator cancel. Numerator denominator cancel one time. Nothing but a by b value is 1. A by b value is 1. Okay, na? See that? Or else in the place of a by b, think it is a 1. 9 by 4 into 1 is 9 by 4. It is satisfying the equation, right? Yes. A by b value is 1. Check. Can I erase that first 4, 5, 6 problems? Yeah. Okay. Check. So problem number 10 here, that is multiply 6 by 11. This number multiply by additive inverse of 11 by 18. What is that? Additive inverse of 11 by 18. What is the additive inverse of 11 by 18? For every positive integer, for every positive rational number, there exists a negative rational number. For 11 by 8, additive inverse is minus 11 by 18. 11 by 8, additive inverse is minus 11 by 18. So denominator 11, numerator 11 cancel. Same way, numerator 6, denominator 18 in 6 three times. That means 6, 18 I have cancelled in 3 table, sorry 6 table. Now check here minus 1, here 1 time cancel, no minus 1 into minus 1 is minus 1. But here denominator 1 into 3 is 3. So answer is 1 by 3. When you multiply 6 by 11 with additive inverse of 11 by 38, we will get the answer minus 1 by 3. Okay now? Now let us go to the problem number 11. That is multiply 5 by 12 by reciprocal of minus 10 by 3. Reciprocal of minus 10 by 36. Reciprocal means the position of the numerator and denominator will be changes, but there is no change in the sign, its sign. That means it is its symbol. Okay. Now what is the reciprocal? Minus 10 by 36 becomes 36 by 10. Now do cancellation, 5 table here 1 time, here 2 times. Numerator, denominator I cancel. Again 12 table here 1 time, here 3 times. 12 3 is 36. Now check, 1 into minus 3 is minus 3, 1 into 2 is 2. So answer is minus 3 by 2. Okay now? So additive inverse means only symbol will be changes. Multiplicative inverse means only numerator and denominator positions will be changes. Multiplicative inverse is nothing but reciprocal. Okay. Question number 12. Now question number 12, while you are observing here, the value of 0.09 bar. 0.09 bar on 09 both. Okay na? It is nothing but repeating decimal. Okay na? Repeating decimal means while you are writing this will be 0.090909 and so on, like this will be repeats. Let us consider it is x. Okay na? Let us consider it will be the x. Here how many digits are repeating? 2 digits are repeating. 0 is repeating as well as 9 also repeating. So that's why this one consider as equation 1 and multiply this equation with 100. Multiply equation 1 with 100. Now it will be 100 into x is 100x, and you are learning the decimal concept. When you multiply any decimal number with 100, the decimal points moves right side towards it. That means here point is will be here. 100 means 2 places, 1, 2, 9 after will come. That means 9.0909 and so on, like this will come. Now x I am writing as it is, that is 0 point, points right point. What is remaining? 0909 like this, 0909 and so on like this. Subtract 100x minus x is 99x. 100x minus x is 99x. And here 9 minus 9 0, 0 minus 0 0, 9 minus 9 all become zeros. Here 9 minus 0 is 9, 9.000 like this come. 9.000 means 9 only. Now next x is equal to, here 99 is multiplies, when you transpose it is divides. 9 by 99, both will come in 9 table, 9 ones are 9 11s are. So x value 1 by 11. Therefore p by q form of 0.09 bar equals to 1 by 11. Okay now? Please note it. That's it for today, children. Have a nice day. Thank you. Bye bye. Please note and go.